In section 4, we're going to write the equation of vertical lines and horizontal lines. They are kind of a special case when it comes to writing the equation of lines that are a little bit different than when we think about the typical slanted line. I'm going to actually scroll down to the next page and start with the graphical one first, and then we'll go back to the written problems after that. If I look at this and I'm trying to draw this graph, I want to identify something that's kind of interesting. And you don't necessarily have to write this down, but just listen as I explain. This point right here is 3 over and 4 up. And I'm going to pick another point on this line. It's 2, or still 3 over, but 2 up. And if I pick another point on this line, it's going to be 3 over and 1 down. And yet another point, it's going to be 3 over and 4 down. Now, a lot of things are changing on each of these points, but there's one thing that remains the same. You'll notice that the x value is always 3. On this line, the x value is always 3. So when you write the equation for this line, the equation is actually going to be as simple as x equals 3. That is the full equation for that vertical line. Whenever you write a vertical line going up and down, all you will be doing is saying what x is equal to, and that's because x will never change. The y value could be literally anything, but x will never change. It will always be that same value. I'll warn you right now that this can get confusing because usually when we think of things that go up and down, we think about the y-axis. The y-axis goes up and down, and yet when we define a line going up and down, we use x. If we want to think about why that is, it's because the y-axis tells us all the different values of y that go up. If you were to write an equation for the y-axis itself, the thing that doesn't change about it is its x value is always 0. So the y-axis is called that because it's all the different changing values of y. But we can't use that to define a line. We actually have to look at what doesn't change. And what doesn't change is the value of x when you're going straight up and down. So that's why it's x equals some number, in this case 3, whenever we have a vertical line. If we slide over to this next one, we have a horizontal line. So this line is going across. And the same idea as we had before, if we were to pick various points along this line, we would get something like -4, 3, or -1, 3, or in this case, +1, 3, and so forth. And what you're noticing once again is that the y values this time are the ones that don't change. So our equation is simply y equals 3, because the y value is always 3 on this line. If this line were going across the 2 like this, then it would be y equals 2. If this one's a little bit difficult, you can use the same logic you used before for why the vertical lines are x, with the horizontal lines being y. You could also think about it as the line y equals a slope of 0, x, plus your y-intercept of 3. And 0 times anything is 0, so that part will just go away, leaving you with y equals 3. So if you have a hard time thinking about it the other way, you can think about it in slope-intercept form and just get rid of your slope of 0. So let's go back to the written ones now above. This one says, if we go back to the previous page, write an equation of the horizontal line through the point 0, -3. If we sketch ourselves a quick graph, 0 over down 3, a horizontal line goes along the horizon, which is going to be flat across like that. Horizontal is across the horizon. We notice that the y value, the height, is always the same. So we are going to say the y value is whatever we are told the y value is. In this case, -3. These examples sure like the number 3. Y equals -3 is the example that we're giving here. We have the same exact point, but this time we're asked to make a vertical line through that point on the next problem. If we were to make a quick sketch of that, 0, -3 is down here. The actual line, a vertical line through that point, is going to be right here. It's going to be the same as the y-axis. But remember, the part that doesn't change is the value of x. So when we have a vertical line like this, you'll notice that this point is 0, -3. Some point up here might be 0, +2. You could find lots of points on there, and the x value is always going to be 0. So we're going to say x is equal to whatever x is, which in this case is 0. So the equation of the vertical line through that point is x equals 0.